I may end up recording 8th period and putting it back up here too. Okay, so Roman numerals. Okay, this is on the periodic table. This is the group B elements, which is the squatty part, scandium, across titanium, vanadium, chromium, manganese, iron, cobalt, nickel, copper, zinc. Those and down. Silver is always +1. It does not need 1. Zinc and cadmium are always +2. It does not need 1. Aluminum is always +3. It doesn't need 1. But every other element to the right, that is a metal, to the right of group 2, up to the staircase, there's more than one type. So in Roman numerals, please tell me I unfroze that. Yes. Capital I means 1. Capital V means 5. Capital X means 10. Now, there are others, but we don't even really use X in this class. But those are the ones that, if you have ever seen them, that are going to be the most common. If you need more than 1, you're literally just going to write an I for how many you need. So I is 1, I is 2, I is 3. This means 1 before 5, which is 4. V is 5. Then if you need to add to 5, it goes after it. So 5 plus 1 is 6. 5 plus 1 plus 1 is 7. There is a 7 somewhere on your homework paper. I want to say it's the manganese because it's the only one I know of that does that. If you were doing 1 before 10, that is IX, which is 9. I've never seen these used in ionic compounds ever. And normally we do not go above 4. These Roman numerals are telling you how positive that metal is, because all metals are positive. All of them. Okay, so that was, I don't know a different way to explain Roman numerals. I plus I, 1 plus 1 is 2, like however many there are in a row, you add them together. If the I is before the next number, then it's 1 below that. If the I's are after the other letter that's not I, then you're going to add it to it. The other thing I saw, since I was not recording, this one. Okay, your negative ions from the periodic table, not the polyatomic ion chart. Y'all, needs to be changed to I, and you had better put the word ion on it. That's an easy fix if you left off the word ion. That's not an issue. Okay, your positive ions do not change to I. You leave them be. So it's the potassium ion. It is K plus 1. Everything in group 1 is +1. It is a, well, except, well, hydrogen is 2. Hydrogen is so much of a weird element up there. Beryllium's in group 2. Be plus 2 is a beryllium ion. It's not berylliide. Only the negatives get changed to that. Let's see, what else did I go over? The polyatomic ion chart. These things. Okay, most of them are ites or eights. Almost all of them are negative, with the exception of ammonium. It's the only positive one. These are the only 3 that do not end in ite or 8. Do not change their names. We will do that when we get to acids, and it's going to make your brains bleed. You're not going to worry about acids for a while. That's a hard one. For right now, you don't change these. Do not forget about these numbers. It's like these are super glued together. A phosphite ion always has 1 phosphorus and 3 oxygens that are literally stuck to it. And together it carries a -3 charge. That is it. That's like saying that a dozen is 12. Why? Because it is. Phosphate is PO4 with a -3 charge. It is still an ion. And once again, you should be putting, if you're telling me it's an ion, you should put that word on there. If you did submit yours electronically, instead of me just marking stuff wrong left and right, just go back and check your submission and redo it if you have to. Trying to think. Okay, so, yeah, like I said, people were Googling, y'all, copper 2. I know it's cupric. I know copper 1 is cuprous. I know iron 3 is ferric and iron 2 is ferrous. I know that, but we don't name these things anymore like that. We use Roman numerals, and the Roman numeral is telling you what the number is. You don't put a plus down here. I know it's a metal. I know it's positive. But these Roman numerals tell you the number positive. And like I said, this ammonium ion, you don't change that. It's 4 hydrogens that are attached to a nitrogen. It's not ammonia. Ammonia is NH3. That stuff, you get it, you sniff it, and it burns your eyeballs. Like, it can actually blind you. It's really good cleaning stuff. It's what makes cat pee smell so bad, is ammonia. All right, so with that said, I'm not ignoring your question. I know I saw your email. I just wanted to get through this first. And once you guys are working on it, I will address your question. So you wanted to know about getting your grade up. I swear I'm not ignoring you. I'm just trying to, if I don't stay focused, like I'm very, very tangential. So yeah, either yesterday or this morning. I didn't see it till this morning. Okay, so in Canvas, you have an opener. I just said it. What is the only positive polyatomic ion? There's only one that is positive on this chart. Do you want a paper version of this? Okay, remember group 1 and group 2 are on the quiz that is on Friday. There's only one that's positive. All of them are negative except for which one? Ammonium. Ammonium. Not ammonia, not pneumonia. Ammonium ion, which is capital N. Yes, capitalization is important. If you do capital N, lowercase h, or lowercase n, lowercase h, it is wrong. It is a nitrogen, which is capital N. It is 4 hydrogens, capital H, and it carries a +1 charge. Now, with your Chromebooks, does control, comma, and control period work for your subscripts and your superscripts? Not in Canvas? It works on docs. Okay, so for your answer, you're going to have to do NH4 and then like do a space and do +1. You're going to have to do it that way. And I noticed that when I made your quiz in Canvas, like I even put it in the instructions saying like, I don't even remember which one I used. Like, let's just say it's this guy, because it's a matching like normal with the quizzes that I have on Fridays. It's going to look like this. Because I can't make Canvas do it. Like I tried for like an hour. I was like, there has to be like an app or something or whatever. It won't let me, but it does say like, because in the instructions I can, in the answer choices I can't, and it's really frustrating. So it'll say up in the part that I can alter it that this is how you're supposed to read it, because you guys really don't have, like, here, let me show you how my Canvas works. You guys really don't have, let's see, did I create a new module? I did not. Here, I'm just going to create a new quiz, new quiz. This is, all right, so if I go into, if I show you how I am, hold on, I'll go as fast as I can. Okay, so in my questions, which you guys don't like ever see us build this stuff. So do you guys have this? Oh, they can't see what I'm doing. You guys can't see what I'm doing. Hold on just a second. Oh, I never got to that. I don't have any balloons left. I can't do it without it. Yeah, but if I start rubbing, it's going to deplete. I guarantee you. Okay, so hold on. For online. Okay, so in your Canvas, do you guys have this button? For your answer thing, do you see this T? Do you see it? Okay, so watch. So if I do NH4 plus 1, watch. So you would highlight this. That makes it a subscript. To make this a superscript, that makes it a superscript. I know it's hard. I don't know if I can make my screen bigger. Oh, I can. Okay, so once again, what I did, now I don't have this option when I make answer choices. Like I said, I can do it in instructions. So if I take it off, take all this off. So you highlight it. This is set for superscript right now. You click on it. Oh no, I gotta hit the tab, subscript. And then you would highlight the next thing. and it's set for superscript, but this is what lets you switch back and forth between them. So now you know how to do that in a text box. So like I said, I've never used Canvas before this year, like ever. So let me go to what we're doing today. Oh no, other things. How do we express a charge in most metals outside of group 1 and group 2? What was one of the things? A what? A Roman numeral. And the I means 1, the V means 5, IV is 4, V, and then I is you going up. There are 4 elements outside of group 1 and 2 that are metals that do not need Roman numerals. What are they? You should have on your colored periodic table, which I have no freaking clue where I put now. There it is. You should have put charges in 3 of their boxes. What did you put inside silver? +1. What did you put next to it in cadmium and zinc? +2. Those do not need Roman numerals because they don't have another option. Aluminum, it's always +3. It's in group 3. It's +3. The other ones in group 3 need more than one. So that was the answer to your opener. This virtual lab, okay, so if you go back into Canvas, and I go back into my chemistry, cadmium, zinc, silver, and aluminum. Oh, it's so slow. All right, so if you go into this virtual lab, you're gonna make a copy. And I'm going to, oh no, that's our space. You guys don't want to learn about rocks. All right, so you want to learn the rocks, so that's Earth space. Now, I actually have this in paper form, but because COVID is just going, like, we can't let you touch stuff. Okay, but I literally have this. I don't know where I put it. Right there. No. Okay, well, somewhere I have this in paper form, and I took. I seriously, there's somewhere in a box where they had these chips, and they literally have. They're like, it's like putting a puzzle together, and so it says group the ion pieces by charge, positive or negative. The positives, the cations, are going to go on the left. The negatives, the anions, are going to go on the right. Oops, so I need to take this off of presentation mode. Your positives are going to have indents. Your negatives are going to be like the opposite of that. It looks like an arrow. So you're going to literally be dragging the ones that are, and you can see positives. See if I can make my screen a little bigger. Come on.
I know which one was that hot pink one that has green indents.
Okay, I don't know if it's going to go much bigger. Okay, that's about as big as it's going to get. So +1 has 1 indent. The +2 has 2 indents. It's looking for 2 other bits if they're individuals. The aluminum is the only +3 on here. But no, that's negative. It's not positive. That's going to go over on the negative side. So that you've got 3 that it does perfectly, but the other ones can go there too. Because well, you'll see on the next slide, this one's just having you sort your cations and your anions. And you can see that O is -2. Okay, and so that means that you're dealing with the motion of 2 electrons with oxygen because it wants to gain 2. With lithium, it has 1. It wants to get rid of 1. So it has 1 electron that it's dealing with. It just happens to be giving it away. Now, if I tried to match up lithium and oxygen, how many lithiums would I need to make it completely flat? How would you fit? How many of these would fit with the oxygen? Because we haven't gotten to that part yet. No. Okay. Well, I'm going to let you guys sort those, which this is an easy part. And then if I go to the next slide, oh, this is so hard to see with, I think that's the next one. Those are so tiny. It's so, 1, 2, 3. All right. So what did I just say that the slots with the pieces, what do they represent? No, just the slot. What does that represent? The hole. What do each one of these generally represent? The motion of a what? What have we been moving when we drew Lewis dot diagrams? Electrons. Okay, so hydrogen, rubidium, and lithium are all dealing with the motion of how many electrons each? How many divots are there in hydrogen, rubidium, and lithium? One. So how many electrons are being moved with each one of those separately? One. Magnesium, calcium, and beryllium are dealing with two divots. So each one of them is dealing with the motion of how many electrons? What? Are you talking about the previous slide?
Yeah.
You should have 1, 2, 3, 4. Oh, they're like stuck down here on the bottom, aren't they? Drag them out of the way. You should have, if you're not counting, well, let's just count the lithium. 1, 2, 3, 4, 5, 6, 7, 8 on the left, and then with the iodine, 1, 2, 3, 4, 5, 6, 7 on the right. Is that what you have?
Yeah.
Okay. You have one left. Where? I'm confused. Let me look. There's one more, I think, positive than negative that's in the group. Oh, they're not equal. Tell you what, let me double check my attendance. Did I go over everybody who did not take their test yesterday? Or did I forget to do that? Okay, online, I see Alexis, Luke, Slate, Luke, Tiffany, Valerie, Brianna, Valerie. Okay, I got my online kiddos right now. Let me go back to this. So yeah, it's not going to be an even amount on both sides. I do believe you have one more positive than you do negatives. But this next one, what did I say? Each one of these divots represents the motion of an electron for each divot. So that means each aluminum is dealing with the motion of 3 electrons. That's because aluminum has 3 and it wants to get rid of 3. Each aluminum wants to deal with the motion of 3 electrons. So if you're dealing with aluminum and something like chlorine, which can only move 1 electron, you need 3 chlorines for every 1 aluminum. That is what this is trying to show you. And like I said, I know I've got paper ones somewhere. I just don't know where I put them. They're in one of my boxes. It's the exact same thing as this virtual lab. It's just catching. Okay, so same thing with the anions. Oh, let me go back. With a cation, are they giving away electrons or are they accepting electrons? If they're positive, they're giving them away, okay? Because the answer is almost the same for anions. Yeah, you're dealing with the movement of electrons, but do anions give them away or do they bring them in? Okay, what charge are anions first, positive or negative? Y'all, it's on the little card. Oh, it's frozen. Anions. These guys. You're still dealing with moving electrons. Bromine's going to move 1, oxygen's going to move 2. But are they giving away those electrons or are they accepting those electrons? Why? You're right. Why do you know that they are all accepting electrons? That's correct. Besides the fact that they're negative and electrons are negative. Let's see. Making compounds. Okay. We are building formulas first, and then we're naming after. I'm used to doing binary both ways, ternary both ways, and then molecular both ways. But we're going to do all the formulas for the 3 major types first, and then we're going to come back and we're going to name them. It's going to be all of next week is giving them names. Okay, so we want to perfectly fit together pieces. So if I go, and don't forget, the negative ion changes to "ide." If it is a polyatomic ion, do not change the "ite" or the "ate." It's really hard for me to see these teeny tiny little tabs. Okay, so this is how these, what we call ion chips, this is, they're digital, they're not paper. If you take a hydrogen and you take a fluorine, they perfectly fit together, like perfectly fit together in a 1-to-1 ratio. Okay, the whole point is to get this to add up mathematically to 0. And what is 1 plus a negative 1, or what is 1 minus 1? 0. So when we write a formula for the hydrogen fluoride, it is 1H and 1F. Y'all, we do not write ones as subscripts. And you can see that each, oh shoot, I didn't mean to do that, and I can't see the, okay. Each of these, it's not, I wasn't trying to double them up. It is a 1-to-1 ratio. So the formula is just HF. We're going to have our notes on building formulas tomorrow for what we call binary, meaning 2 different element compounds. Okay, potassium and oxygen. These are the samples that are already done for you. You're just using this. Now, why is there 1 potassium? I'm going to duplicate this. Hold on, I got to make it bigger. I can't see what it says. Oh, come on now. Not letting me. Why are you not letting me make this bigger? Here. No. There we go. I need to duplicate you. Copy. I don't know if it's going to let you. Is it going to let you use that twice? Or do I need to go into my original? Oh, okay. Well, anyways. Will it let you? Okay. So you have 1 oxygen. Okay. It wants to gain 2 electrons. It's going to gain 1 from this potassium and 1 from this potassium. And if I line it up the right way, you need 2 +1 potassiums for a total of +2. 1 plus 1 is 2. To cancel out the -2 from the 1 oxygen. The whole point is these need to add up to 0. So the formula, oh, this is so annoying, but this is the only way I know how to do it when I'm sharing my screen, is going to be K2. This tells you how many of the element was before it, O, and it needs to be a subscript. Once again, on a Google slide, you should be able to highlight it and either hit Control period or Control comma. One makes a superscript and one makes a subscript. And then you guys are going to be building your own. The whole point is to not have pieces sticking out. So that does not work. You have a missing hole. Now, sometimes, if I go back to this slide, sometimes they match up perfectly. And we have a 1-to-1 ratio. So the formula for aluminum nitride is just ALN. Once again, do not write a 1 as a subscript. If there's more than 1, then you need a subscript. And then the rest of this is really what is on yours, is you are building the compounds and then you are writing the formulas off on the side. And then there are some where you're filling in, these are not in the right place. You have to drag them. You have to drag them where they belong. So they're just, I did not move them anywhere in particular. Miss Castleberry made it. So these aren't necessarily in the right spot. They need to be moved into the right spot. Okay, now let me stop. We got 15 minutes. Let me stop the recording.